Hello, mathematicians. Today we are going to talk about a strategy for multiplication called partitioning rectangles. Say that with me, partitioning rectangles. But first, let's warm up our brain with this multiplication number story on page 111 in your math journal. If you're not there yet, please pause the video to get your math journal and turn to page 111. Maya wants to lay tile on a floor that is 8 feet wide by 24 feet long. The tiles she wants to use are 1 square foot each. How many tiles will Maya need? So I'm going to look at what the question's asking. It ends in a question mark. It says, how many tiles will Maya need? Underline that. So we've read the problem to understand it. So for my plan, I'm probably thinking, okay, let's follow the steps. Step one says, draw a picture to represent Maya's floor. So if I know it's 8 feet and each of these little cubes or units is a foot, I'll go 8, draw this on your page too, 8 by 24. Go ahead and draw this on your page too. I'm counting by fives to help me make it a little faster. Okay, so you should have a fairly large rectangle that's 8 by 24. Pause if you need more time to draw yours. And now I feel I'm ready to answer the question, how many tiles would she need? So I have a visual. I could count up each of these little tiles inside her floor. But please, I hope you don't do that because that would take you way too long. The answer is over 100, and that would not be the most efficient way for you to find the solution. So I want you to pause the video and try to figure out how many tiles this is. There are many strategies you could use. See which one works for you, and then play back the video when you're ready to see one possible strategy. Oh, and make sure that you explain your strategy, please, once you've tried it out. You can explain with words or with equations, just so we clearly know how you solved. Play back when you are ready to see a solution. So you probably realized, right, we need to know if this is a 24 by 8. We're using multiplication to find out how many are inside, the area inside. And one strategy is the partitioning rectangles. That's the one I want to show you today, where you literally take the rectangle and break it into parts. So perhaps you just did kind of traditional multiplication with this. I'm going to show you the partitioning rectangles way to solve. So I would look at this 24 and think of it as 20 plus 4. Right? So then I can break my rectangles apart and just cut off 4 here and 20 here. And the reason I did that is because 20, that's a multiple of 10. That's really easy for me to multiply by. And 4, single digit, that's easy for me to multiply too. So now I can find the area of these smaller rectangles, no problem. Now I just have to do 8 times 20, which, well, I know 8 times 2 is 16, 0 in my factor, 0 in my product. So this has an area of 160. And here, 4 times 8 is 32. So now I have how many tiles are in each of my smaller rectangles. I just need to add those partial products together. And I get 192 tiles. You can give a woohoo if you got that too. I'd be interested to see if you tried the same strategy or if you solved it a different way. Let's practice some more of this partitioning rectangle strategy. I'm going to skip the explain for time, but I would like to read your explanations of your strategy. So let's look at this one where it says steps to problem solving. Let's read them together on the count of 3. 1, 2, 3. Read to understand, plan, solve, and check. Let's read the problem. Regan rode her bike 4 miles a day for 39 days. How many miles did she ride in all? So what's the question here? How many miles did she ride in all? I'm going to underline it. Now it asks for an So I know what the question's asking. Sorry, check off that step. Now my plan, well, if she rode her bike 4 miles each day for 39 days, I'm going to think of that 39 days with 4 miles each day is 39 times 4, right? This asks for an equation. Is this an equation? Because I need an equal sign. So I'll say equals, it wants how many miles, let's call it M for miles. You can pick your own unknown if you want it to be a different letter or even a heart, whatever your unknown symbol is. Okay, so let's solve this multiplication by partitioning rectangles. So I'm going to draw a 39 by 4 rectangle. And you, again, I could have written this 4 times 39 equals M. That would have been the same thing. You could have your rectangle rotated the vertically. I like the horizontal way, makes it easier for me to get my picture right. So now I have 4 times 39. Instead of thinking of this as 39, I'm going to break it up or partition, break into parts my rectangles, and I have to think of an easy way to break up 39 into products that I can do. Well, 30 is going to be easy to multiply by, and 9 is just a single digit number. So I expanded that out to, you could even do a plus sign here if you wanted, because 39 is just 30 plus 9. And now we're in business, because to find this first area, we can do 4 times 30. That's just an extended fact. 4 times 3 is 12. 1 0 in my factor, 1 0 in my product. 9 times 4 is 36. So am I done? Not quite yet. Now I have to take those two partial products and add them up. And finally, I will get 156. So, and it's 156 softballs, 156 pieces of paper. No, 156 miles. Okay, so I had my plan, I solved, and I'll check. Did I answer the question, how many miles she ride in all? Yes, check. And does it seem reasonable that she would ride, if she rode 39 miles, sorry, 4 miles a day, not 39 miles a day, that would be a lot of miles, 4 miles a day for 39 days? Yeah, that could be 156 miles. It's not like I got something crazy like 3,000 or even, a larger number. That seems to make sense. And this shows what's called the distributive property of multiplication, but more on that in a moment. Right now, I want you to try one. Feker scored 35 points per game in the 6 games that she played. How many points did she score in all? So let's see what the question is asking here. How many points did she score in all? So we've read to understand the problem. Let's set up our equation. So if she played for 35, she earned 35 points. Good job, Feker, by the way. 35 points in each of her 6 games. I'm going to do 35 times 6 to find out how many points in all. Now, is this an equation yet? Right? You must have your equal sign. So I will put equals. I'll use P for points. Now, I want you to pause the video and do the rest. Solve this problem using the partitioning rectangles strategy, show your picture, and play back when you are ready to see the solution. Okay, so you should have gotten 210 points. Give a woohoo if you agree. And let's take a look. You can see in my picture, I split up 35 into 30 plus 5 because those products were much easier for me to find mentally with extended facts and basic facts. And once I had my partial products, 180 and 30, I added them together. And then finally, the question asked, how many points? I made sure I said 210 points. Check yourself. Did you include your units as well? Give yourself an extra pat on the back if you did. So this is what you'll be practicing today, the partitioning rectangle strategy, being able to draw a visual. As a little bonus, because I think math is so cool, I want to show you some other math notation that that you'll see as you get older, and that shows this partitioning rectangle strategy just a little bit different way. So this is called the distributive property of multiplication. Say that with me, the distributive property of multiplication. And what it means is that if we have a problem like 35 times 6, actually, just I'm going to write it as 6 times 35 because those are the same, right? Doesn't matter how I write it, but it's just a little easier for me to see. Okay, so we have 6 times 35. Well, because multiplication, the operation we're doing here, is distributive, you could write this, actually, just because 35 is 30 plus 5, you could write this as 30 plus 5. And I'm putting that in parentheses to remember that that all stays together. Okay? And now, here's the fun part. Since multiplication is distributive, you can just multiply by the parts and then add them together, right? So if I distribute it, I'm doing 6 times 30. And then I'm also doing 6 times 5. And I'm adding them together. And hey, don't those look familiar? 6 times 30. That's what we just did in our visual model. And 6 times 5, that's what you just did in your visual model. So again, we have 180 plus 30 equals 210. So that's just some fun math notation to show you how it looks as we describe this distributive property that you can multiply by the parts. Enjoy practicing this strategy, and I look forward to seeing your work.